All right, our fifth and final type of reaction that we're going to look at are what are called combustion reactions. A combustion reaction occurs when a hydrocarbon reacts with oxygen, always oxygen, to produce energy in the form of heat and light. So there are other types of combustion reactions, but we're only going to take a look at hydrocarbons reacting with oxygen. So here's an example. Methane, CH4, reacts with oxygen to produce carbon dioxide and water vapor. The products of a combustion reaction will always be carbon dioxide, CO2, and water, H2O. So as far as predicting products, this type of reaction will always be the easiest. You just have to know that it's always carbon dioxide and water. Now, catch this, it's water vapor. That means even though it's normally a liquid, there's so much heat and energy given off that it's water in its gaseous form. Not its liquid form, but its gaseous form. So this would be the one time where you're writing a little lowercase g behind water instead of the lowercase l. So here's an example. Write the balanced chemical reaction for the combustion of liquid ethanol. All right, we may not know what state of matter ethanol is. Luckily, we can read and they can tell us, they will tell us, that it's a liquid. All right, because we just did our lesson on organic chemistry, we know ethanol, Eth means two carbons, OL means that there is an OH on the end. If it helps, go ahead and draw out the structure. Well, you're going to end up with C2H6O. So it's a combustion reaction. We know that inside of a combustion reaction, there's always our hydrocarbon. Here we have that. And it's always going to react with oxygen. Always oxygen. You've heard of stop, drop, and roll. You've heard of smothering a fire. The idea is when you're doing those things, you're removing the oxygen from the reaction, and so the reaction ends. So always remember that O2 is a vital component of every combustion reaction. That's going to be your second reactant in every type of combustion reaction we work with. Predicting products, again, is going to take a little bit of memorization, but really it should be pretty easy. We always know it's going to end up with carbon dioxide and water vapor. So there are our products. As easy as it is to predict the products, always carbon dioxide and always water vapor, it's a little bit more challenging, or it can be a little more challenging, to balance the reaction. I always like to start with my carbons. So in this case, I have two carbons. So I'll put 2 over here on the right-hand side. Now I've got 2 carbons and 2 carbons. I usually try to wait and do oxygen last. So the next thing I'll look at are my hydrogens. I have 6 on this side and 2 on this side. By adding a 3, now I have 6 H's and 6 H's. Finally, we need to take a look at our numbers of oxygens. On the left-hand side, we have 1 here in ethanol and 2 more in oxygen. So we have 3 total on the left. On the right, we have 2 times 2 is 4 from our carbon dioxide and 3 from our water. So that's a total of 7 on the right. And we've got 2 ways to manipulate our number of oxygens. If we can help it, let's try to work only with our molecule of oxygen. Because if we put a coefficient out in front of C2H6O, we're going to have to change all the numbers of carbons and hydrogens on both sides, and then we'll just have to completely rebalance. So if we place a 3 in front of just the oxygen, that gives us 6, and 1 more is 7 oxygens, and that is indeed what we're looking for. So there we go. We've got a balanced chemical reaction. Finally, put in our states of matter. Again, you may not know off the top of your head what ethanol is, but go back, read the question. It's a liquid. Oxygen is a gas. Carbon dioxide is a gas. And water, this is the one to be aware of, it's water vapor. So in a combustion reaction only, water should be a gas.